All right, we're looking for two 3-digit numbers that give us a very large palindrome, or the largest possible. So there's a couple examples here, just multiplying 3-digit numbers together. We find, well, there's a palindrome right there. So a number that read forwards, read backwards is the same number. For us, we're looking for a big one, so why don't we just look for one that starts with a 9, which means it has to end with a 9. And we need to figure out what this ABC number is, this DEF number, and then figure out ultimately what their product is. Looking at the left-hand side here, I know we're multiplying two 3-digit numbers. I can expand these out, 100A plus 10B plus C. And when we do this multiplication, we're going to notice that every term has something in common except for the last term. And that is every term's divisible by 10, but we don't know if C times F, the last digit of the first 3-digit number, the last digit of the second 3-digit number, is divisible by 10. So this whole multiplication is really modulo 10 C dot F. Modulo 10 gives me the last digit, and I want my last digit to be 9. So I want C dot F to be 9 mod 10. And there's not many ways to do this. So we can actually look at a multiplication table modulo 10 here. So we're dividing by 10 and taking the remainder. Imagine the top row there is F and the left column is C, and their multiplications are the entries. There's only 4 ways to make this happen. So that gives us a very strict condition for what the last digits C and F are allowed to be. And we learned this by looking at the left-hand side of our equation there in the middle. So now let's go ahead and take a look at the right-hand side and see what we can come up with. We can do a similar expansion here on the right-hand side. Let's put in some placeholders here. I don't know the numbers, so let's put in letters. And now we can write these out into the powers of 10. And here, because we know that this has a palindrome property here, terms are going to repeat. We're going to get 2 of each term, and we can combine those terms. And when we combine those terms, we see that all 3 of those coefficients there, those numbers there, are actually divisible by 11. And we can factor out 11 from the entire right-hand side. And what that tells us is that this palindrome is something times 11, doesn't matter what it is, which is another way of saying that our final answer is going to be divisible by 11. And that gives us our second fact here. And so now what I want you to do is take these 2 facts, give the video a pause, and try and figure out how to combine them in a way that gets you the final answer. And I've provided here a little app that lets you play around with that. Best of luck. Let's give it a go. We can start with the divisible by 11. So the product is divisible by 11, which means that one of these numbers has to be divisible by 11, as 11 is prime, so one of the factors has to have a prime factor in it. If I additionally assume, because we're looking for big numbers, that each 3-digit number starts with a 9, there's only so many options for multiples 11 that start with 9 in the 900 range there. Okay. Now using our second property here, if I know I start with a 9, I'm divisible by 11, well, can I narrow that down further knowing that the last digits have to give me 9 mod 10? There was only 4 ways to do this. And so the last digits, C and F, I don't know which one's C and which one's F really, or which 3-digit numbers first, but there's only so many possibilities for what these last digits can be. We see it's really, your last digit better be a 1, 9, 3, or 7. And so we're going to get rid of all these multiples 11 that don't have last digit 1, 9, 3, or 7. This leaves us with 3 scenarios. One of our 3-digit numbers is 913, 957, or 979. And if you tell me the first number, I know the last digit of the last guy. 7 and 7 have to be paired up. 9 and 1 have to be paired up when we're just talking about C and F here. And so that gives us these 3 scenarios where the only thing I don't know is E. Now, when I build these out, letting E go from 0 to 9, I'm not guaranteed to find a palindrome. I'm just hoping that there are 2 3-digit numbers that start with a 9 that give me a very large palindrome here. This isn't guaranteed, but if I find a palindrome out of these 30 options here, or more than one, I'll take the biggest, this will ensure there's no bigger one, because I've made my assumptions from top down. And here we actually find a palindrome, this 906,609, which is our final answer. Thanks for watching. I hope you've enjoyed. Go ahead, hit the like and subscribe, and I'll see you next time.